Hey everyone, welcome back. Today, we're going to learn about using Spring JdbcTemplate to update data and how to handle transactions. I'll show you how to write update queries with JdbcTemplate, and we'll also cover how to make sure our database changes are safe and reliable using transactions. Let's start coding. Alright everyone, take a look at my screen. In our update employee method, we're first checking if the employee ID exists in our map. If it doesn't, we throw an employee not found exception. But if it does exist, we update the employee's name, age, and department. But we need to save these changes to the database now. Let's change the code so it saves the updates in the database. Follow along with what I'm doing. Alright everyone, let's move on. Open the employee repository interface. We're going to add a method called updateEmployee. It will take an employee object and give us back the updated employee. Now let's open our employee JdBC repository and override the updateEmployee method. Let's write our update query step by step, as you can see on my screen. Type update, employee, set. First, we update the employee name. Then, we update the age. We won't touch the joining date since that's fixed. Next, we update the department. Finally, we add a where clause to target the correct employee using the employee ID. Alright everyone, our update query is ready. Now, let's call the update method of JdbcTemplate to execute it. Pass in our query along with the corresponding parameters. First, the employee name. Then the age. Followed by the department. And finally the employee ID. Update method of JdbcTemplate returns the number of rows updated. Let's print that out. Return the same employee object as our response. Our update employee method is now complete. Just take a look at my screen. We've written the update query, executed it using jdbctemplate.update, and we're returning the updated employee object. Now, let's move over to the employee service class to integrate these changes. Before we update an employee, we need to make sure that the employee actually exists. And guess what? We've already implemented the findByEmployeeID method in one of our previous videos. So, let's call that method. If our optional is empty, it means no employee was found, so we throw the same employee not found exception as before. Next, extract the employee object from the optional. We're going to update the fields one by one. Setting the employee name from the DTO. Updating the age. And finally, the department. Next, call the updateEmployee method from our employee repository to save the changes to the database. Next, convert the updated entity to our DTO using our entity DTO mapper and return the response. Alright everyone, all the changes are done. Now it's time to start the application. Now open Postman. Now it's time to test our update operation. I am going to update the employee with ID 3, changing the name to Harsh Patel and the age to 31. Before we perform the update, let's first call getEmployee by employee ID for employee ID 3 to check the current details. As you can see on my screen, the current details for employee ID 3 are showing as name John and age 34. Now, let's update this record. Awesome, we got a success response for our update. Now, let's hit the getEmployee by employee ID endpoint again to check the updated details. See my screen, our updated details are clearly visible. The name now shows as Harsh Patel, and the age is 31, confirming that our update operation was successful. Alright everyone, here's an important next step. Right now, we're fetching and updating records. But what if two people try to change the same employee at the same time? That can lead to conflicts and data inconsistency. To prevent this, we need to lock that row before updating it. This way, only one update operation can modify it at a time, avoiding conflicts and ensuring data consistency. Open the Employee Repository interface. Copy the existing FindByEmployeeID method and paste it. And rename the new method to FindByEmployeeID for update. Open the Employee JdBc repository. Do the same. Copy the FindByEmployeeID method code, paste it, and rename it to FindByEmployeeID for update. In this new method SQL query, add for update at the end. The for update clause locks the row returned by our select query, ensuring that only one update operation can occur at a time. For more details on how database locking works, be sure to check out the official documentation. Let's open the Employee Service class. Now, instead of calling FindByEmployeeID, we'll call FindByEmployeeID for update. This ensures that we lock the row before updating, so no other transaction can modify it simultaneously. Alright, here's an interesting twist in our service layer. Currently, we're running two queries. First, we fetch the employee data with a lock using our forUpdate clause, and then we perform the update. But there's a catch. If these two queries run in separate transactions, the lock from the first query will be released immediately because the connection's autocommit is enabled by default. This means the row wouldn't actually be locked when the update occurs, which could lead to conflicts if multiple updates happen concurrently. Now, you might be thinking, so, do we have to manually manage the transaction by setting autocommit to false, then explicitly calling commit and finally resetting autocommit to true? That would be a hassle, right? Well, here's where Spring Boot makes our lives much easier. Spring Boot provides the @transactional annotation. By simply annotating our service method with @transactional, Spring automatically wraps all the operations within that method into a single transaction. This means the employee is fetched with a lock. The lock remains in effect until the entire method finishes execution. Once everything is done, the transaction is committed and the lock is released. This ensures that our lock remains in place throughout the update process, keeping our data safe and consistent without any manual transaction management. Alright everyone, let's restart the application. Now we're going to update the details for employee with ID 10. First, let's fetch the current details of employee ID 10. Take a look at my screen. It's showing that employee ID 10 currently has the name Vikas and is 38 years old. Now let's update the details. We're going to change the name to Vikas Kumar and update the department to developer. Hit the API. It was a success. Now, Let's fetch the details once again to confirm that the update went through correctly. See that? The name has changed to Vikas Kumar, and the department is now developer, exactly as we intended. Now, you might be wondering, how do we confirm that the record isn't updated by another request while it's in progress? To simulate this, let's add a thread.sleep in our code. Now hit the update request. Watch what happens. While our update is paused due to the sleep, try updating the same record from dbeaver. Notice that it hangs, which confirms that our locking is working as expected. Let's cancel the simulated delay and remove the thread.sleep from our code. Alright everyone, here's a quick summary of what we covered today. We implemented an update operation using Spring JdbcTemplate. We handled transactions using a transactional to ensure data consistency. We added a row lock using for update to prevent concurrent updates. We even simulated a lock scenario with thread.sleep to demonstrate how the record stays secure while being updated. In the next video, we'll tackle how to delete records. Thank you for watching. Please subscribe, hit that notification bell, and leave a comment if you enjoyed the session. See you in the next one.